right, so that is our quotient rule formula. Okay, so let's say, for example, you wanted to simplify log of base 4 of x over 64. Okay, so we know because it's a quotient, log base 4 of x over 64 is just going to equal log base 4 of x minus log base 4 of 64. Now, log base 4 of x, that one can't really be simplified anymore because we don't know what the x is, so that one stay the same. This one, you can sort of see a relationship between 4 and 64. So you have log base 4 of 64 equals y. Okay, so we know that 4 to the power of y equals 64. Okay, so just like before, 4 times 4 is 16, and 16 times 4 is 64. So that means 4 to the third power is 64. So we know this would be true for y equals 3. So that means this entire term just becomes 3. So that gives us log base 4 of x minus 3. Or a log base 4 of x over 64 equals that. Okay, any questions on that one? All right, I'll leave that up there for a few more seconds. Okay, so what if we have to simplify, say log of xy over 10z. Okay, we know it's a quotient, so we're going to use the quotient rule. That means log of xy over 10z is just going to become log. Remember, there's no base, so log base 10 of xy minus log base 10 of 10z. Let me make that. There we go. Okay. Now, once we apply the quotient rule, that actually gave us two products. So we can apply the product rule to both of those. Okay, so if we apply it to this one, that's going to be log base 10 of x plus log base 10 of y. Actually, let me move that over. Make it a little lengthy. Okay, so that's going to equal log base 10 of x plus log base 10 of y. Okay, so now we do the same thing here. So this will become log base 10 of 10 plus log base 10 of z. Okay, so that's minus, actually let me use the brackets just to, parentheses will work. Okay, so this becomes log base 10 of 10 plus log base 10 of z. Okay, so you have those two that you just kind of expanded. Okay, now the reason I use the parentheses is that, remember, this is minus this term. And all we did was convert this term to this one. If we didn't use the parentheses and apply just the minus here, we're not applying it to the entire thing. So you have to, well, you might want to remember to put the parentheses because it kind of reminds you to distribute that negative. Okay, so this becomes log base 10 of x plus log base 10 of y minus log base 10 of 10, and again, minus log base 10 of z. And again, with or without the parentheses, same thing. Okay, so log base 10 of x, y, and z, can't do anything with those. But you see your base 10 and 10 has a relationship. So log base 10 of 10, if we make that equal to y, we know that 10 to the power of y equals 10. And the only way that's true is if y is equal to 1. Okay, so this term just becomes 1. So that gives us log base 10 of x plus log base 10 of y minus 1 minus log base 10 of z. Okay. Any questions on that one? Okay, so sometimes you have to do multiple, or apply multiple properties in the same problem. Okay, I'll leave that up for a few more seconds. Looks like everyone's done writing. Okay, and now we have the power rule for logarithms. Okay, just like before, we're going to apply it for all positive real numbers. M, and instead of M and N, we're going to use M and P. And our base doesn't equal 1. It means if you have the log of base B of M to the power of P, that equals P times log base B of M. That just means that exponent just comes out to the front. All right, so quick proof of that one. Okay, so what if we let M equals B to the power of X? this actually converts to log base b of m equals x. B to the power of x equals m, just converts. Okay, so that means if we have our log base b of m to the power of p, we can replace that m, so it becomes log base b of b to the power of x times p. Well, to the power of p. Okay, so we can just go ahead and multiply those two together. So you have log base b of b to the xp. Okay, so we know this just kind of goes down to the front. So we have xp times log base b of b. Okay, so we can see that log base b of b is just equal to 1. Okay, so that means log base b of m to the power of p is just equal to p times x. Okay. We already identified x up here, so that's equal to p times log base b of m. So that's how we got our formula. All right, so let's say, for example, if you have log base 5 of 36, and you wanted to simplify it. Okay, so with this one, log base 5 of 36, you can just make that log base 5 of 6 squared. Okay, so that exponent comes down to the front. That's just 2 log base 5 of 6. And really, that's as much as you can simplify that one. Unless you make 6 equal 2 times 3, that would be log base 5 of 2 plus log base 5 of 3, and that's just not simplifying it, you're making it longer. Okay, so let's say if you have log base 10 square root of 10. So we know square root of 10 is just 10 to the 1/2 power. Square root of 10 equals 10 to the 1/2 power. So this will just become log base 10 of 10 to the 1/2 power. Okay, which means our 1/2 can just come right out to the front. That's 1/2. I don't really need that one. So 1/2 times log base 10 of 10. Okay, but this part can be simplified because 10 and 10 has a relationship. So you have log base 10 of 10 equals y. So 10 to the power of y equals 10. So this is only true when y is equal to 1. Let me clean that up a little. There we go. So that means that y is equal to 1. So this really becomes 1/2 times 1, which is just 1/2. Okay, so let's say we also wanted to simplify. Say log of base b of x squared y to the third z. Okay, so we know here we have our product rule because you have x times y times z. So log base b of x squared y to the third z just becomes log base b of x squared plus log base b of y to the third plus log base b of z. So apply product rule. Okay, so we have our product rule. Now we want to just bring down our exponents. So if we bring down our exponent here, we have 2 log base b of x plus 3 log base b of y. That's an exponent of 1, so it stays the same. So we have log base b of z. Okay, so sometimes it's really depending on how they word it. Sometimes they'll have you keep it as one term, or sometimes they'll tell you to make it into a sum of logarithms. It all depends on how they want that particular problem. Okay, any questions on that one? All right. Leave that up for a few more seconds. Okay, so let's say, for example, we wanted to simplify log of y to the third and the fourth root of x divided by z. Oh, sorry about that. All right, so the first thing you notice is that it's a quotient. So you apply the quotient rule. Okay, so that means you have log. If you want to, you can put the 10. So you have log of y to the third fourth root of x minus log of z. So you have the log of your numerator minus your log of your denominator. Okay. Now you apply the quotient rule, but here you're going to apply the product rule. Okay. So that becomes log of y to the third plus log of the fourth root of x minus your log of z. Okay. So it's only one term on the other side of this minus sign, so you don't have to worry about parentheses there. Okay. So now once you apply the product rule for these two, you can apply the quotient rule. I mean, not the quotient rule, the power rule. Okay, you just have to remember that the fourth root of x is equal to x to the 1/4 power. Okay, so that gives us log of y to the third plus log of x to the 1/4 power minus log of z. And we just bring down our exponents. So you have 3 times log of y plus 1/4 times log of x minus log of z. Okay, and that would be your final answer. All right. Any questions on that one? Okay, so there are 2 things you want to remember. Because I actually see these mistakes quite often. First, log base b of m divided by n does not equal log base b of m over log base b of n. Looks like it should work, but it doesn't. And 2, if you see log base b of m plus n, that does not equal log base b of m plus log base b of n. Okay. Again, looks like it should, but it doesn't. So I figured I'd point those out, hoping that if you see it, you won't make these mistakes. All right. Any questions? All right, I'll leave that up for a few more seconds. Right, so let's say for our first example of that one, what if we want to write the expression as a single logarithm? we have 16 log base 8 of x plus 1/3 log base 8 of y. Okay, so before we applied the product rule, the quotient rule, and all of that to make it stretch out. Now we're going to convert that to just one term. Okay, so I'm just going to rewrite it. So 16, no, not 16 plus 16 log base 8 of x plus 1/3 log base 8 of y. Whenever you see that plus sign, that's how you automatically know you're going to use the product rule. Okay, because if you remember, log base b of m times n, that's just log base b of m plus log base b of n. So all we're doing is going in reverse. Okay, so as long as your bases are the same, you can combine them. The only problem is, before you do that, you have to get rid of those coefficients. Okay, so that means you use the product rule. Okay, so applying power rule. That means that 16 goes up here. So you have log base 8 of x to the 16th power. Plus log base 8 of y to the 1/3. Okay. So now we have those coefficients. Now we can apply the product rule. So if we apply the product rule, okay, so that plus sign just means that this becomes log base 8 of x to the 16th times y to the 1/3. Remember, that's your m and that's your n. You're just multiplying them now. Okay, so actually you can leave it like that, or you can just make it log base 8 of x to the 16th and cube root of y. Okay, so either one of those will work. So you got both of those terms, combine them into one. All right. Any questions on that one? All right. I'll leave that up for a few more seconds.